Greetings, I'm Dev the Developer.
And I'm Glitch.
We just spent a whole video talking about what classes and objects are. Now we're going to write one. This lesson covers the C# syntax for defining a class, the difference between fields and properties, and the two ways to create instances. So let's build a class. In C#, you start with the class keyword, then the name, then curly braces. Everything inside belongs to the class. Glitch, give me an empty person class. A few naming conventions to lock in right now. Class names use Pascal case. Every word capitalized. Bank account, shopping cart, person. The name should be a noun, a thing, not an action. And each class typically lives in its own file named to match, like person.cs.
Wait, so the file has to be named the same thing as the class?
It does not have to be. The compiler does not care, but it is such a strong convention that you will see it in every professional C# project. The name mismatch will confuse everyone who reads your code, including yourself in 3 months. Now, let's add some data. The simplest way is a public field. A field is just a variable declared directly inside the class body, not inside a method. Each instance gets its own copy.
Okay, so that just looks like regular variables. That was way simpler than I expected.
Right, and that simplicity is the problem. These are public fields. Anyone, anywhere in your program can assign anything to them with no rules at all. Null, empty strings, a negative age, nothing stops it. Fields also use camel case, not Pascal case, which is a signal that they are intended to be internal. You will almost never use public fields in real code. There's a better option. That better option is a property. The simplest form is an auto property. You write the type, the name, and a get set block. And C# handles the hidden storage for you. Get means allow reading. Set means allow writing. Together, get set means anyone can both read and update the property. From the outside, it looks like a variable, person.firstname. But it is actually a controlled access point. The backing storage is there. C# just generates it automatically and hides it.
So there is storage, I just do not see it.
Exactly. And when you want to add rules to that storage, that is when you write the full property syntax. In the full form, you declare a private backing field yourself and write out the getter and setter bodies. That leading underscore and lowercase name is a convention for a private backing field. The compiler does not require it, but everyone expects it.
So value is a special keyword inside the setter. That is the incoming assignment, and I can just check it before accepting it.
That is exactly right. You can accept it, transform it, or ignore it entirely. In this case, we are rejecting empty strings. The first name only gets updated if there is actual content.
That's actually really powerful. You could use that to filter out anything that does not meet your criteria, like rejecting any input from callers that have not provided the right access token for the secured resource. I mean, rejecting empty strings. That is what we are doing here.
Yes, for a first name specifically.
It was just an example.
There is also a third accessor option, init. It works like set, but only fires at object creation time. After the object is created, the property is locked and nothing can change it. That is useful for data that should genuinely never change once the object exists. You set it once and the class locks it down. That brings us to creating instances. You have two styles. The first, to call new and then assign properties separately. The second is the object initializer. You create and assign in one expression. Both are valid. The object initializer is more compact and you will see it constantly in C# code. The properties you set need to have set or init for this syntax to work. Properties are one of those things that seem like a small syntax detail until you realize they are doing a lot of quiet work keeping your data clean. A field will accept anything. A property is where the rules live. Go write a class, add an auto property, then a full property with at least one validation rule in the center, and see how differently they feel when you actually control what goes in. Don't just watch it. Do it.